All right, so looks good. We're online. Now, welcome everybody. And thank you very much for your interest in our webinar of K2 Systems. Today we will introduce our new flat roof mounting system to you, which is the Dome V. My name is Marco. I'm from Product Management. And next to me, my colleague Ronnie.
Thank you very much. Hello and welcome also from me. Welcome to the Base On webinar for our new flat roof system Dome V. I'm Ronnie. I'm in technical sales department, and I will show you how to calculate a project with our new flat roof system Dome V in Base On. But first, Marco will show you a presentation about it.
Let's have a look at the agenda. So first of all, I will show you a few slides. So we talk about the new system in theory, and then later on we will show you the samples that are lying on the table next to me. And in the end, Ronnie will show you how to plan a system with our tool. And of course, there will be plenty of time to answer questions. You can raise the hand at all time, or you can just write your questions into the little window. Okay, now you're supposed to see the presentation. Probably, first of all, a rough explanation about the name, Dome V. D stands for double elevation, S for single elevation, and the V comes from the shape of the system. On the left-hand side, you can see the double inclination of the modules. It looks like a V. So the name comes from that shape, and Dome V is for east-west inclination, and S for usually a south inclination of 10 degrees. Now, some features of the system. It is based on our already in place system D-Dome and S-Dome, which is probably already the 5th generation of this flat roof system. And what is very new to the system is that it absorbs tolerances of the roof. We will show this later in detail, but the protection mat has a very unique feature, which is to absorb tolerances. So basically, it compensates movement of the PV panels. So the forces that are created for wind, for example, are not transferred to the roof protection foil. It is a short mounting rail system, so the rails are not continuously, but they are cut, which brings us also an advantage that the tolerances can be compensated. The flexible EPDM support pad, which I mentioned before, compensates these tolerances and has at the same time a better friction coefficient, which is important against movement, so we can reduce ballast. Also, we lowered the transport volume, so we reduced cost for logistics, but also material cost. Here we can say it's definitely a cost reduction of at least 5% in comparison to the last system. And when we talk about rising material, aluminum prices, this is quite a good achievement. So instead of raising the prices, we're going down with the price with this new system. And of course, it is aerodynamically optimized, as usual, based on wind tunnel tests. You can see here it's very less components. It's one rail, aluminum rail, with integrated ballast trays. So the ballast stones can be placed directly into the rail. In black, you can see the EPDM protection mat with this honeycomb structure, and of course the other parts like the modular clamps, for example. Same for the S-dome. It's almost the same components. Of course, there's one additional component, which is the windshield. All right, we have realized first reference projects. Here you can see the S-dome 200 kilowatt system, which we built in Germany, Hanover. And the same also for the D-dome system, 700 kilowatt D-dome system was built just last week in Oldenburg. I think the installers liked the installation despite the rainy day. All right, now let's go over to the table and we have a look at the real parts. All right, now we can have a look at the parts. Here, I think we can start with this part. This is the rail, including the protection mat that you can see here. At the same time, the ballast trays are integrated, so the ballast stones can be placed in here. Just as usual, you probably know our sliding nut, which is very easy to be mounted here. And then we go in with this part, which is, we call it the base part of the dome. And here you can also see it's very easy. You can't go wrong with the installation here. One screw. So this is basically the only tool that you need for the whole installation. So this one is fixed.
After that come these two parts. Easy to install because it's not possible to place them
in the wrong way.
This is not possible. It's the so-called Poka-Hoke principle. Put it in the middle until it's fixed.
Exactly. So the position is fixed. This is the higher elevation point. And when we look at this part here, so this one is the lower fixing point. So the module lies from here to here. And you can see this one has no screw connection. This one has only, it can be placed and mounted with this turn in function. And we are flexible until you screw down the panel. So all in all, we have only one fixing point in the whole system, which is this one. Everything else will be just clicked in, turned in.
And here this part will be fixed as soon as you fix the middle or end clamp with the modules simulated by these tubes here. And now you can see as soon as the clamp is fixed, you cannot move it anymore. So a big advantage is you have only one screw here and no additional screw beside of this clamp screw for this part.
Exactly. And then you go on with the module clamps, which are just slided in here. And then of course, just clamp the module as usual. The clamp is suitable for a wide range of modules. So basically it's one clamp that fits all the module sizes.
Of course, the single elevation system is very similar to this double elevation east-west system. Here the single elevation system S-dome V, which looks very similar, but of course with one possibility for an elevation only, but with a possibility for the fixation of the windshield on the back.
Perfect. Then probably it's nice to show the function again of this protection mat. Of course, it protects the roof, as the name is implementing, but at the same time, you can see here the movement that is going on top will not be, how to say, weiterleiten.
Well, the mat will tolerate the movements of the system itself.
Exactly, it absorbs the movement that is going on here, and the forces are not being implemented into the roof itself. Okay?
Okay, so
perfect.
Let's go on with the calculation.
Yeah.
So this is the start page of our calculation software based on. I suppose that everybody already has an account and knows how to register, and so we go over this point. But I want to mention this window. Please take the time and always read the updates and the news which are shown here to you. They can be very valuable for you and for your based on knowledge. For example, here we inform you that now we can calculate buildings up to a height of 50 meters. So you are welcome to click read more and yeah, get informed about our latest news. Now I will dismiss this window because we want to start calculating. So this is already the mask for a new project, but we can also use this button if we were already in a project. So we use the button new project and then come to the next page, project. I will choose a project in Germany, but not where my pin is. So I will choose a location here in Renningen, where we are with K2 Systems. It's in the Industriestraße. So this is the Industriestraße, and I can zoom out a little bit with the wheel of my mouse and choose my window, which is over here, and I can scroll in again, and now you see our pin is still here in Industriestraße, and I can choose my project, my building, my address by just double clicking here, and then the address will be the right address here from Benzstraße, as you can see now. Even the number 43 is added here. Only then we have the right wind and snow loads. So please always be sure to enter the right complete address. Of course, I can give my project a name. I can add my name as the author of the project, can add the name of the customer and of the contact person in the customer's company. Okay, but let's just go on to the next page, roof. We have a situation here now that we have two roofs or even three roofs. Let's concentrate on these two roofs here. This one is a little higher, and I can add my first roof by using the plus. It's a flat roof, and as soon as I choose flat roof, the system shows me two possibilities, polygon and rectangle, and we will start with a rectangular roof. And already the system knows that a flat roof cannot be a tile, trapezoidal, standing seam, or corrugated roof. I cannot click on all these fields, but only on the flat roof sign here on the right side. Then I click on Add and go to one corner of my roof, the outer corner, not the inner corner inside of the attic, but on the outside of the attic. And I click, I move the mouse, very easy. I click again, and then I move the mouse again, and I finish my roof. Maybe I have the real measurements of my roof, and maybe I know that it's not 23.12 meters and not 21.06 meters. I can alter the size of the roof by using the mouse like this, or by switching over to the 2D view here on the upper right side. And then I can type in the actual measurements, and I can tell the system that the alternation shall take part on this side or on this side or on both sides equally. I choose this arrow and I type in the real measurements here. What was that again? 18 meters. I go to the map view again. Oh, it's a little too small. Let's do it like this again. So 23.5 meters. Let's take this value. And maybe 21.3 meters. Yeah, let's have another look. Okay, looks good. Maybe it's a little too big. Also very important is that you type in all the values properly. Building height, maybe my customer told me that the building is 9 meters tall. The pitch is 2 degrees, and I have a parapet wall of 0.3 meters, and the friction coefficient for our new MAD-V on roofs with a membrane, you can choose 0.5 as friction coefficient. Now we see we have a big obstruction here on the roof. We can add an obstruction. In this part, we have the possibility to choose between 3 different obstructions: polygon, rectangular, or just a line. This one obviously is rectangular. The first line of our obstruction is always parallel to the roof, to the roof lines. I can give my obstruction a height, let's say 0.5 meter, and a distance which is not to be set by the photovoltaic construction. Let's say this is 30 centimeters in this case. I can also show the shading of the obstruction on the 21st of December. This one here would be my obstruction. Later on, you can use this the shading. You can use this simulation of the shading for deciding if you want to place some modules here or not. So I will disable the shading now and go to design. Here you can choose your module between, you can have the choice between many module manufacturer. If your manufacturer is allowing the modules to be clamped on the short side, which is necessary for the dome systems and also for the new Dome V systems, then the manufacturer will be in this list. You can also choose a user-defined module. Then you have to type in the actual measurements of your modules here. You can also type in the name of the manufacturer and name of the type. And please be sure to read the assembly instruction of the module to be sure that the module is allowed to be clamped on the short side. So let's proceed to the next step, module array. We can add one again by using the plus. Let's start with a D-dome V, the double elevation system. As soon as I click on this symbol, the system shows me that the module orientation has to be landscape and of course elevated but not parallel to the roof surface. Now you have the choice to use complete roof or module field. Even if you want to place the modules over the whole roof, I recommend to use this button, module field, because you are more flexible later if you have some need to alter something on the roof. So I click on add, and now I see a yellow line here. The yellow line is the default distance from the edge of the roof to the module fields. I start to draw my module field just in the corner, just on the yellow lines. I pull the module field over the whole roof. Of course, you can also alter the edge distance of 60 centimeters, which is shown by the yellow line. Maybe if you have a safeguarding or something on your roof, and you have to go further from the roof edge. So maybe you can type in 2.5 meters, and then you have your yellow line further inside. Yeah, let's keep the 60 centimeters for this project. Here you have a spacing of 2.13 meters between each double module here. You can also type in a smaller value like 2 meters, but then you will see that it has to be 2.06 meters at least. Of course, you can also use a little larger value, then you will have a little more space between the rows. If you have to do some work between or on your PV station, then you can it's just easier to walk between the rows. Now let's just go on and have a look on the next page. Here we see that the calculation of the loads has taken place automatically because I am my project is in Germany, and we have a national attachment for Germany. For many other countries, we also have these national attachments, but you will see if your country is also in this list or not. If not, of course, you will have to type in your wind and snow load manually. But in this case, you see we already have our values here. We can check again the category. Here we are in a industrial area. So this is category 3, pre-assembled or default value here is 2, 3. So let's go on 3. And let's just proceed to the next page, results. Now it's calculating, so we wait a little. And then you see we have a thermal cut up here. And we probably also have another one, which should be here. So this is not the ideal solution. Maybe we can do this a little better. Let's go back to design, switch to the 2D view. Maybe it's easier when we make the gap a little smaller. Yeah, now we can see it better. We can show the thermal gaps by using this button. Now we can edit it. I can say to the system now, okay, I don't want this thermal gap, but this won't work. The little hook here will come back because I have to have a thermal gap after 7 modules. I can also try to make a thermal gap every 9th row, but it doesn't work. It always goes back to the least value of 7. Now I have 2 possibilities to alter this thermal gap. Of course, the best solution on this roof seems to make the thermal gap just in the middle. So I put it here. Now the yellow line gets thicker. That means I have the thermal gap here now. And now it's also possible to remove this thermal gap after setting a new one here in the middle. So this is one possibility. The other possibility would be just to type in 5 here, because we have the thermal gap here after the 1, 2, 3, 4, 5th row. Of course, the same is possible with the thermal gap in this direction. Here it could be nice or it could be the best solution to let the thermal gap here, because then we already have kind of a gap here, and we also have this row. But I suppose that it will be better for the ballast results if we alter this thermal gap too. So now we just have a look. We have very low ballast values here. 18 kilograms only is the maximum value, which is up here. And on this large module fields, we have no ballast at all in the middle and just a little ballast on the outer edges of the field. Let's just try what happens when we move the gap. So let's put one maybe here and remove this one. So now you see that the maximum value is even lower. It's not 18 kilograms anymore, but 10.5. So we could reduce ballast to by optimizing the situation of the thermal gaps. Let's now have a look to the ballast capacity here. You see that the dome, or in this case our base rail, can take a ballast up to 30 kilograms, and for a ballast more than 30 kilograms you would need additional items, a speed porter or even a porter when your wind loads are very, very high, and therefore the ballast also is very high. So now if we go to summary, we should not be any additional parts for ballasting, which is true. Let's go back for a second. You would also be able to alter these values if you maybe knew, okay, my stones are a little lighter than average stones, and maybe I can only place that amount of stones, and all in all these stones have only a weight of 28 kilograms. Then you would need additional parts for ballasting if you have a ballast value of more than 28 but not 30 kilograms as before. With our old dome system, we had the different building protection mats with or without aluminium on the bottom side, but here we showed you the dome mat V, which is good for membrane and for bitumen also. So let's go back and draw another roof, which would be this one, which is now a polygon roof. So we go to this area again, we add a new roof. It's again a flat roof. This time it's not rectangular but polygon, and it is also membrane, bitumen or gravel. So I start drawing the first edge of my roof again. And now it's automatically, it jumps from 45 degrees to 90 degrees. If I want to give my roof an angle between 45 or 90 degrees, I can do this by using the Shift key on my keyboard, and then I can give my roof an angle with any value. If I take my finger off the key, it's 90 degree again. So in the end, it's not possible. Yeah, it is possible. I can use this the control key to have two 90-degree angles in the end. I make a double click then, and my roof is finished. I type in the friction coefficient again. Maybe I have a parapet wall again of 30 centimeters. The roof pitch is 2 degrees again, and the building before was 9 meters, so maybe this is only 7 meters. We have obstructions here again, rectangular obstructions. And now we have the possibility to copy or to duplicate these obstruction. I have 1, 2, 3, 4, 5 more to set. I can do it by using this button. 1, 2, 3, 4, 5. I take the last one, put it here, and the next. First, I have to activate the obstruction before I can move it. It's always activated when the 4 dots in the corners are visible. It seems that we have 2 more obstructions here, so let's just duplicate it again and put it down here. I could also draw new obstructions, of course, but I also can use existing obstructions and just make them a little smaller than like this. Yeah, it also makes sense to just make a obstruction as a line here, because we should not build our system over this line, so it's necessary to have an obstruction here too. I double click and then I say the distance shall be 30 centimeters. And now we proceed to the side design. Don't forget to go again to this area, because now you have to choose a module again. Before we've chosen a user-defined module. So I click on this button and then I will have the same module here again. We take, let's take a S-Dome V system this time. And add a module field again. I can pull the module field all over the roof. And in this area where my roof has ended, of course, there are no modules. Let's switch to the 2D view again to have a little better overview. You can again see the thermal cuts here. Maybe we can optimize that again. So a good position for the thermal cut would be here, in my opinion, because here we have no modules at all. So let's say here is a thermal gap. Let's see what happens when we remove this one. Okay, we have another thermal gap here, but let's put it again into the middle of the roof. Maybe it's better for the ballast values in the end. And let's also put this one more in the middle. Remove the other one. And now let's have a look to the thermal gaps in this direction. Yeah, maybe we should place both of them a little more southwards, like this. If I remove this one, there will be set a new one after 10 modules, which is a good position, I think. So we can remove this one again. Okay, let's deactivate the thermal gap edition mode. And of course, we should save our project from time to time. Let's go to loads again. Again, we have the loads calculated automatically after a short time of waiting. And we go to results. And now you see that we have a different ballast capacity for the S-Dome systems. Before we had 30 kilogram for the rail, and now we have only 20. This is because the rails for the S-Dome system are a little shorter in this case than the rails of the D-Dome V system. Now we have a message here. Our building has a special type. It's not rectangular, but it has kind of an L shape. If you have projects like this, download it, please, by using this button and send it to us at service@k2-systems.de, because our research and development department has to check if the ballast values are are realistic. For polygon roofs, these values have to be calculated manually again, and just double checked. Yeah, if we go to summary now, we see that we have 2 roofs, and our item list is quite long because we have a combined list now of 2 systems, the D-Dome V system and the S-Dome V system also. You have, beside of downloading the base on file itself by using this button, you also can download several documents like the PDF document, which consists the static report and all the parameters of your project. I've just downloaded it, so let's open and have a look. Here you have all your project data for roof 1 only, then the module layout, the ballast plan. If I zoom in a little bit, you can see, oh no, it's not the ballast plan, sorry, it's the rail plan. Here you can see that you have longer rails on the very right and very left rails is always a longer one, and then in between it depends on the module field size, if there are long rails only or short rails as well, like here. If we go on, we have all the ballast values, and here also very interesting, the pressure on the roof, or the weight of the module blocks. Like here you see the ballast for module array 1, 2, 3, and 5. Here you have the weight of the system all in all. That means ballast plus mounting system plus modules for each module array, and here for all blocks. And this is the dead weight for each module block for square meters. So you have 0.1 kilonewton per square meter dead weight for module array 1, and for the other ones 2. So this might be an important value for your project and for your building. Here we can see that the system has been calculated successfully, and here we have the bill of materials for roof 1. Following, we have the same for roof 2. I will just go over this because it's the same, more or less, the verification of the system again. Bill of materials for roof 2, and then the bill of materials for both roofs. Besides of the PDF, you also have the possibility to download the bill of material as an Excel file. I think I don't have to show that to you because it's just what you can see here, but in an Excel file. Interesting also could be the ballast plan as an Excel file, because this gives you further possibilities. For example, you can do further planning here for roof 1, module array 1, roof 2, module array 1. Yeah, it's for all module arrays actually, not only module array 1 like shown here. But what you could do here, what customers do, is planning the strings for the project in these Excel files. So I have a short look. Seems that we have no questions. My colleagues already answered some questions. From my point, yeah, that was it. The calculation of the new systems. So feel free to ask questions.
Yeah, probably just to add, it's also possible to see the prices along with the bill of material. Therefore, please contact us, and then we can release this version to you, and you can see the prices directly with the bill of material. So it's very easy for you. You can calculate the system, get as a result the bill of material with prices, and that makes it very easy for us to cooperate. So yeah, one question was about the friction coefficient. The worst value with our MED-V that we have tested so far was 0.55. So this is what you can use if you want to be safe. But you could probably get a better result by testing it on the roof.
With our friction coefficient measuring device.
Exactly. Very easy, very simple tool. So within 10 minutes, I think you spending on the roof, you will have this result and probably save some ballast by having a better friction coefficient.
Yeah, this could be a good invest, because then you have the actual coefficient, but not just a coefficient which is guessed. So yeah, your ballast values are really like they should be.
Yeah.
And probably you can save some stones or some ballast.
Then another question was about the values, the load values. So we have wind and snow values. Here for Germany, as Ronnie showed you, the national appendix will automatically draw here loads. So here within the program, all the loads will be automatically drawn from the Eurocode with the national appendix. Now we're working all the time on implementing new national appendixes into our program. For Europe, we have most of them. Sweden is in progress, for example. Some other countries are in progress. We are implementing step by step all international appendixes into our base on. So until this is the case, you need to manually type in. Probably you can show it here. So here manually, then there's two values that you need to type in, the wind load and the snow load. Yeah, if you have problems with the load values, just call us, give us a quick email. We can help you for all locations. That's no problem at all. Okay, perfect. Then I would say we've finished the official part. We are still online to answer your questions. So please stay online if you still have any questions. Otherwise, we say bye from our side.
Goodbye, and thank you very much. thank you for taking part, and have fun using Base On, and have success by planning your projects.